Part 2, sorry, we're actually looking for the range this time. Okay, so this is question 6, part 2. We're looking for the range, and just to remind us that the actual it's 70i and 140j. So 70i plus 140j is the initial velocity of the object. So we want to find the range. So as usual, we could do this in several different ways. We'll just take one way because I've done it in both ways in question 3 to find the range. So I'm just going to use the method of I'm going to find the time of flight. Okay, so if I imagine this thing gets fired up the J at 140 and this way at 70, and it goes up and it comes back down over here. It's supposed to be a proper projectile, not a very good one. Okay, so imagine that's the projectile, it's a bit better. Okay, so if that's projectile, now we want to do our U, V, A, S, and T, and this is Y equals. So what we're trying to find is the time of flight. If we can get the time of flight, right, so that's the time to here, this is the time of flight, the time it takes to get to here. So if we knew that, we multiply it by 70, then we'll know the distance, and that's the range, okay? So the range, of course, equals Sx max, that's what a range actually is. So the initial, so the, if we think about this, so when at this time here, the distance in the y direction is actually 0 there, and it's also 0 here. So there's 2 times when the distance in the y direction is 0. Right. So actually the time it takes for this to go up and come back down is the same as the time as it takes to go from here across to there. So if I said the initial velocity is 140, and if I said, well, the final velocity would be 140 in the y direction, because it'd be coming straight back down at that point, then the acceleration is 9.8 as usual, and the actual distance will be 0. Why is it 0? Because it's a displacement, remember, it's not a distance. Okay, so this is, remember, actually displacement. So if it starts back in the y direction where it finished, then it's being displaced in that direction by nothing. This is the time of flight, and that's what we're actually looking for, time of flight. So let's use V equals U plus AT. Fill in what we have. We have minus 140 for V. We have U at 140 minus 9.8 divided by T. And that's what we're looking for, T. So that means it's minus 140 minus 140 divided by minus 9.8 equals T. So that means that T actually equals minus 280 divided by 9.8 minus. That would mean that the time of flight is actually 28.6 seconds. Okay, so that's the time of flight. So the distance x max is equal to the velocity in the x direction multiplied by the time. So if you travel at that velocity for this time, you'll go this distance. So that means it's 70 times the 28.6 gives me an s of x, or also called the range. So the range is actually going to be 70 times 28.6 is, I get 2002 meters. So that's it.